Okay, looking at some application problems with direct and inverse variation. Number 5 talks about the force of an object and it being inversely proportional to the square of the distance that the object is from the center of the Earth. Okay. Now, lucky for us, they give an approximation in this problem, the distance to the center of the Earth as being 4,000 miles. So what we're going to do here is we set up our inverse variation. We're going to put the weight of the astronaut in here of 230 pounds, and we're going to put the distance to the center of the Earth as 4,000. What we're going to do then here is we're going to cross multiply to find our K value. Okay. So again, find K, and then once we found K, we can answer the second part of the question that says, what's the astronaut's weight when they move 100 miles off the surface of the Earth? Okay, so if you think about this, we know they're giving us that this is 4,000 miles here, and then the astronaut moves off 100 miles. So now the astronaut is 4,100 miles from the center of the Earth. So we can just do that on our calculator, and what we end up finding out is that it does say round to the nearest pound, okay, that the astronaut's weight is 219 pounds. Then next it says that the distance that an object falls is directly proportional to the time that the object is falling. And so they tell us an object fell 99 feet in 2 seconds. So we have to remember that it's the time squared here. So what we're going to end up doing here is we're going to end up dividing by 4 here, okay? And then we find out that our K value is 24.75. So again, find K, and then use K to answer the second part of the problem. In the second part of the problem, it says, how far will an object have fallen after 8 seconds? And so, again, don't forget to square this. We put our K value in here, and then we can just do this on our calculator, and we find out that the distance the object fell was 1,584 feet. Okay, so the setup is super important. Take time to get your variation set up correctly, and then substitute, solve K, and then use K.